Have you heard the news? The headlines are buzzing, lighting up our screens with a truly astonishing claim: Earth has a second moon. It sounds like the opening line of a science fiction novel, a sudden dramatic plot twist for our planet's long and lonely story. For 4.5 billion years, we've looked up at our one constant silver companion. It's been the subject of poetry, the goal of explorers, the silent witness to all of human history. The moon is a fundamental part of our world and our identity. So, the idea of another one, a newcomer suddenly appearing in our cosmic backyard is, well, it's mind-bending. It challenges our most basic understanding of the sky above us. What would that even be like? A night sky with 2 moons. Would our tides change? Would ancient myths need a new chapter? The questions are as vast as space itself. But before you start imagining 2 giant, luminous orbs battling for dominance in our night sky, let's press pause. As is so often the case with groundbreaking scientific announcements, the reality is a little more complicated, and honestly, a lot more interesting than the headlines suggest. What astronomers have actually found isn't a new, permanent sibling to our moon. It's not a rival, or a companion in the traditional sense. The truth is, our celestial family hasn't grown by one permanent member. Instead, we've just noticed a temporary visitor, a cosmic tourist, taking a brief fascinating detour through our neighborhood. So, what is this mysterious visitor? If it's not a true moon, why is it sticking around at all? And what does its presence tell us about the hidden dynamics of our solar system? That's the core question we're going to unravel. To do that, we first need to be crystal clear on what it actually takes to earn the title of moon. You see, to be a moon in the classical sense, an object needs to be a natural satellite, locked in a stable, long-term orbit around a planet. Our moon is the undisputed heavyweight champion of this definition. It's enormous, about a quarter the diameter of Earth itself, making it the largest moon in the solar system relative to its host planet. It's gravitationally dominant in our immediate vicinity. Its pull is powerful enough to stabilize Earth's wobble on its axis, giving us a more stable climate. And most importantly, its orbit is the very definition of stability. It's been with us for billions of years, and it's not going anywhere. It is a permanent defining feature of our world. That is the gold standard. The story of our moon's formation, the leading theory of which is the giant impact hypothesis, suggests it was born from the Earth itself, forged in a cataclysmic collision with a Mars-sized protoplanet billions of years ago. It's bone of our bone, rock of our rock. This shared origin story and its immense size and gravitational loyalty are what make it moon. Any other object aspiring to that title has some very, very big shoes to fill. This new object, however, is a completely different beast. It's more of a cosmic hitchhiker, a drifter caught in a complex gravitational dance. It's what scientists call a temporary captured object, or TCO. Some are also referred to as quasi-satellites. Think of it less as a permanent resident, and more as a tourist who has checked into a cosmic hotel for a short stay. It hasn't signed a long-term lease. It hasn't been gravitationally bound to Earth in the same profound way our moon is. Instead, it's an asteroid, likely from the asteroid belt between Mars and Jupiter, that has wandered a little too close to the Earth-Sun system. Its trajectory was just right to be temporarily snagged by our planet's gravitational influence, but it's still primarily orbiting the Sun. It's like a car on a racetrack that briefly drafts behind another car before peeling off onto its own path. This is why the term quasi-satellite is so fitting. It orbits the Sun, but its orbital period is so similar to Earth's, almost exactly 1 year, that it stays in our general vicinity. From our perspective on Earth, it appears to be looping around us in a strange, kidney bean-shaped path. But if you were to look at it from above the solar system, you'd see both Earth and this tiny object orbiting the Sun in near-perfect tandem, with the object just wobbling back and forth relative to our planet. It's a gravitational illusion, a temporary partnership governed by the complex interplay between the Sun, the Earth, and the object itself. Eventually, the subtle gravitational tugs from other planets, or even just a slight change in its own trajectory, will allow it to break free from this dance and continue on its own journey through the solar system. Its visit is, by cosmic standards, incredibly brief, lasting anywhere from a few months to a few hundred years. So let's be absolutely clear. This isn't a giant glowing orb that will change our tides, inspire a new wave of romantic poetry, or give werewolves a second reason to howl. These objects, often called mini-moons, are incredibly small. We're talking about rocks that are typically just a few meters across, the size of a car, not a celestial body. They are also incredibly faint. You would never, ever see one with the naked eye. They are thousands of times fainter than the faintest stars you can see on a dark night. They are only detectable by our most powerful and dedicated survey telescopes, which constantly scan the skies for anything that moves. Their visit is fleeting, their presence almost imperceptible. But don't be disappointed. Just because it's not a second moon in the way we might have imagined doesn't make it any less incredible. In fact, the story of these mini-moons is a fascinating and crucial glimpse into the dynamic, ever-changing nature of our solar system. It's a reminder that space isn't a static, empty void with planets locked in perfect, unchanging clockwork. It's a busy, chaotic, and constantly evolving environment. Asteroids are always on the move, and our planet is constantly interacting with this cosmic debris. These temporary captures are a natural, and likely, common, part of that process. We're only just now developing the technology to spot them. Each one we find is a new data point, helping us understand the traffic patterns of our solar system, the population of near-Earth objects, and the delicate gravitational balance that governs our cosmic neighborhood. So while the headline might be a myth, the science behind it is a breakthrough.